8.2, we're adding and subtracting rational expressions. That means fractions. So remember way back when we added fractions, we couldn't add something like that until we get a common denominator. 1/2 plus 1/3. I don't know until I change to a common denominator. That's what we're going to have to do today. All right. The hardest problems are going to involve factoring. So keep in mind, you got to remember how to do your easy trinomial, your hard trinomial, your difference of squares, your GCF. You got to remember how to do that stuff for the hardest ones. All right. So find the LCM. LCM. I think it's easier probably to do the variables. X to the fourth means this, and x squared means this. Y to the third means this, and y to the fifth means this. All right. So, you know, what do both of them have? Least common multiple. Okay. Well, you could say, well, both of them have x squared. Okay, that's true. Both of them have x squared. But that's not exactly what we need. Okay, we need to make them both happy. And in order to make them both happy, we can't take any of this guy's x's away. All right. And so what we're going to end up doing is, since the guy on the left has 4 x's, we're going to have to give the guy on the right a couple of x's. So now they're both equal. They both have the same. They both have the same number of x's. Now, if you look at the guy on the right, and the guy on the right has 5 y's, we're going to need to match that over on the left. All right, we want them both to match. And so for the LCM, we want them both to have the same thing. Okay. And if they both have 4 x's and 5 y's, they're going to be happy. So the least common multiple is definitely going to have x to the fourth and y to the fifth in it. All right, but what about the numbers, the plain old numbers? So on the left side, the 4, we can think of that as 2 times 5. I mean, not 2 times 5, 2 times 4, 2 times 2. Getting ahead of myself. We can think of 10 as 2 times 5. All right. So look at the numbers, look at the factors the same way as we looked at the x's and the y's. The guy on the left has a couple of 2's, 2 times 2. And so we're going to do the same thing over on the right side. The right side only has 1 2, and so we're going to give it another 2. All right, so now they both have 2 2's. The guy on the right has a 5. Well, let's give the guy on the left a 5 as well. And so if you can do that, they all have the same thing. They both, left side, right side, have a couple of 2's and a 5 and 4 x's and 5 y's. They're now the same. They're now common. All right. So clean this up. 2 times 2 is 4 times 5 is 20. That's your LCM. Now, the good news is we don't have to do that every time. And once you figure it out, it's a lot faster. All right. So I know that took kind of a long time. That doesn't come up all the time. We'll come back to that. All right. So basically what you want to do is factor. And so 12v plus 28 over here on number 2, we can take out a factor of 4, and that's 3v plus 28 right there. No. Man, I am all over the place today. It's not 3v plus 28. It's 3v plus, anybody know? 7. Very good. Okay. So, you know, think about it as 2 different people, I suppose. And the person on the left has a 4 and a 3v plus 7. And the person on the right has just v plus 3. We need to make them the same. And so what I'm going to do is I'm going to give the person on the left a v plus 3. Now they both have a v plus 3. Now I'm going to give the person on the right a 4 and a 3v plus 7. All I'm trying to do is make them the same. That's what we're going to have to do with our fractions. Common denominator. We're going to have to make this least common multiple here. All right. So if you look at what they both have a 4 and a 3v plus 7 and a v plus 3. That's your LCM. All right, that's your LCM. That's going to be necessary. That's going to be a necessary step for the hardest problems. We're not there yet. All right. Simplify each expression. We're just going to add the fractions. See fraction plus fraction? If I do fraction plus fraction, I need a common denominator. But if you notice, I have a common denominator. So when we have fractions with a common denominator, if I said 7 over 2 plus 3 over 2, I would just say 7 plus 3 is 10 over 2, right? That's how fractions work. If it's a common denominator, you just add the top. And so that's all I'm going to do in this problem is, since it's a common denominator, add the top. So if you look at the top, you've got x plus x is 2x. And then you've got 5y plus negative 5y. That's 5y plus negative 5y is 0. It cancels out. So I don't even need to put anything. That's just going to cancel itself out. So my numerator is just 2x. I'd say 2x over 12y cubed. And that would be the answer, except I can reduce this. 2 goes into 12 6 times. We always have to reduce our fractions. And so after reducing, I have x over 6y cubed. All right, not so bad. Let's look at number 5. We're subtracting fractions this time. But subtracting fractions, adding fractions, it's really the same thing. If you've got a common denominator, it doesn't have to be that hard. All right, so I can see right now the denominator is 6x times x plus 2. So I know my answer is going to be something over 6x times x plus 2. And you can go ahead and write that now if you want. Look at the top though. X minus x. That's going to be 0, right? That's going to cancel out. All right. Now, don't forget that minus sign, because a lot of people will miss this and they'll say negative 6 plus 1 is negative 5. But it's minus, right? It's negative 6 minus 1 is negative 7. Now, if I could reduce, I would, but I don't see anything that's going to reduce, so that's the answer. Look at number 7. We're adding fractions. We need a common denominator. We have a common denominator. That denominator is 6u. So I know my answer is going to be something over 6u before I even go. All right, so we look at the top and we say 6 plus, I don't have any like terms. You can't say 6 plus 4u is 10u because those are not like terms. 6 plus I don't know what is 6, and nothing plus 4u is, you're just going to have that, 6 plus 4u. All right, now here's the hard part. There's something that reduces here. Okay, it's not the 6. It's not the u. It's not the 4 and the 6. Okay, here's what's hard. In order to cancel this one, you're going to have to factor. All right, and so up on the top, I see a GCF pattern. Both of the top numbers, 6 and 4, have a 2 in them. And so I can rewrite this as 3 plus 2u right there. All right, the factoring is going to get, that's going to be hard because you're not going to remember when to factor. You have to make yourself. We can only cancel things that are factors, things that are being multiplied, like this 2 is now. I can now reduce a 2 into a 6, goes 3 times. So I've got 3 plus 2u on the top and 3u on the bottom. You can't cancel those 3's. You can't cancel those u's. That's all you can do. Number 9. We're subtracting fractions, but we have a common denominator. So, great. We've got 30mn. You can go ahead and write that. We know that's the denominator. Numerator, just combine your like terms. I've got m minus m. That's 0, so that's gonna fall out, right? Now be careful here. You've got 4n minus negative n. Right, that's minus negative. That's going to be plus, right? So 4n plus n is 5n. Now, since there's no plus sign in my answer or minus sign, I don't have to worry about weird factoring or weird canceling like I did on the last one. I can just cancel. I know that 5 goes into 36 times, and these n's will cross out. And so we're left with a 6m on the bottom. Doesn't look like there's anything on the top, but when that happens, what do I put? 1 over 6m. Okay. Problem 11. I know that looks complicated, but you see how the denominators match? If the denominators match, we can just go straight to it. I know the answer is going to be something over this. So just combine your numerators. 3p plus 5p is 8p. There's nothing that reduces here, so that's your answer. That's it. That's all there is to it. These problems do not have to be hard. The hard part is when you're going to have to factor. And that's what's going to come up on the back, I think. All right. Number 13 is the first one where we have to add two fractions that don't already have a common denominator. All right. So think about what we can do. We can call this a fraction, 2x over 1. And this is what I was talking about in the first two problems up there at the top. If you want to add fractions, you've got to give them a common denominator. So see how the one on the left has an 8y cubed? I'm going to have to give the one on the right an 8y cubed. Now, technically, you can't do that, right? You can't just put that on the bottom. You have to multiply the top and the bottom. Because what I've just written in red is equal to 1. And all I've done is multiplied by a really special form of 1. I haven't changed the value of my numbers at all. All right? So I'm multiplying by this 8y cubed over 8y cubed to change it so that I do have a common denominator now. So if you think about it, you've got 5y over 8y cubed plus, and then this one is 16xy cubed over 8y cubed. Not bad. Okay. Honestly, well, we're not done yet though, right? Now I have fractions with a common denominator, and so I can combine them. I know my denominator now is 8y cubed. Your top, 5y, is not like terms with 16xy cubed. So if they're not like terms, you can't combine them. Best you can do is just kind of write them next to each other. You're going to have 5y plus 16y, xy cubed. Now, if you can reduce, you have to reduce. And technically, since, see how all three of those terms have a y in them? I'm going to do a GCF here. See how there's a y? This has a y in it. So take out that y times 5 plus y times 16xy squared. Boom. Now I'm going to cancel that y with one of those y's, and there's my answer. All right, this one's pretty hard. Left, remaining on the top, I've got 5 plus 16xy squared, and on the bottom, I've got 8y squared. Can I cancel out that y squared? Absolutely not. Now, one thing I probably should have showed you, see how we canceled out that y? I could have saved myself some time if I had noticed that in the first step. If I had canceled out that y here in that first step, I wouldn't have had to cancel it out in the last step. So I guess the moral of the story is if you can reduce, as soon as you can reduce, reduce. All right? So we look at this next problem, 15. Do you see anything in this problem that can reduce? These twos, not the other twos, but those twos can. Okay? Reducing those twos in the first step will make this problem go faster. All right? So we've got to, if we're adding fractions or subtracting fractions in this case, we've got to make it fair. We've got to get a common denominator. And this one has a 5r plus 2. All right? The other one does not. So we need to give this one a 5r plus 2. Only we have to do it top and bottom. 5r plus 2, 5r plus 2. We're multiplying by 1 there. On the left side doesn't have a just plain old r. So we're going to multiply the one on the left by just plain old r. We do this so that they're both the same. Now they both have a plain r and a 5r plus 2. So I guess what we can do maybe is clean up what we see. I know the bottom is going to say r times 5r plus 2. But let's see what the top says. Okay. Right here, I've got r times 2. Let's call that 2r. And notice you've got minus 1 times 5r. So that's going to be minus 5r. But what everybody misses, everybody forgets that you've also got minus 2 right here. All right, minus 2 right there, minus 2. Okay, there's something I can clean up because I have like terms right here. 2r minus 5r is negative 3r. There's not much else you can do. Minus 2 over r times 5r plus 2. Got it. That's it. Okay. Next one. If there's anything that you can reduce, you probably want to do it first rather than last. It doesn't really matter. You either do it first or you do it last. See how this 2 will go into this 6 3 times? That might help. But on the left side, on the left fraction, you see how 4, 2, and 6 are all divisible by 2? If 4, 2, and 6 are all divisible by 2, then you can reduce this by 2. All right. So, usually what we'll talk about is on the bottom, there's a GCF. And now that 2 will go into that 4 2 times. All right. So I know that's kind of hard to see what's happening. So maybe I'll just rewrite the whole problem. Okay. If you don't want to do that, then don't worry about it. But I've got 2x over x minus 3 plus 3 over x cubed after the reducing step. Okay. Now, x minus 3 is its own thing. It's a binomial, so you can't really count that x with the x to the third. All right. The one on the left has x minus 3, but we're going to give it x to the third. The one on the right has x to the third. We're going to give it x minus 3. All we're trying to do is make them the same. Yeah, I know. Okay. So the denominator now, both of them have an x cubed and an x minus 3. So that's the denominator. Look at what we have on the top. Over here on the left side, we have 2x times x cubed. That's 2x to the fourth. And then over on the right, you've got plus 3 that's going to need to get distributed there. So that's going to be plus 3x. And plus 3 times minus 3 is minus 9. There's nothing we can reduce there. That's the answer. Okay. Number 19. I see one thing that can reduce right off the bat. See how that 2 can go into that 4 twice? You're going to have to reduce that either at the beginning or at the end. It doesn't really matter, but it's probably going to be easier if you reduce it at the beginning. Okay. So see the fraction on the left? It has an x minus 3. What does it need? It's going to need an x. See the one on the right has an x. What's it going to need? Exactly. So you're probably going to need to put parentheses around these just to see what's going to happen. You're going to have to do some distributive property on the top, I think. We've got the denominator. The denominator is an x and an x minus 3. The numerator's got some stuff going on here. Distributive property gives me x squared minus 2x. And then we've got to distribute a plus 2. So if we distribute that plus 2, that's going to be plus 2x minus 6. Now I see something that'll clean up. 2x minus 2x is going to be gone, right? That 2x minus 2x is going to cancel out. Okay, negative 2x plus 2x. X squared minus 6 over x times x minus 3. I can't cancel that x. I can't do anything. That's the answer. All right, next. No GCFs. Nothing really to do. The one on the left needs a 3n. The one on the right needs 2m squared. Doesn't have to be hard. All we're trying to do is make a match, making them the same. So the common denominator now, 3 times 2 is 6 nm squared. Both of those denominators have 6 nm squared. We're going to distribute 3nm minus 15n squared. And we're going to distribute. Pay attention to this plus. If it's a minus, you have to, if it's minus, it's harder. But if it's plus, we can just distribute this plus 2m squared right there. That's going to be plus 2m cubed plus 2nm squared. Do I have any like terms? Do I have any GCF? Not like. So there's nothing really to do. This one looks really complicated, but there's nothing else to do. Okay, almost done. 23. Do you see something to cancel at the beginning? The 4 is very good, and the x is very good. So I'm gonna reduce that to 5 halves minus 1 over y squared. That's just going to make this a little bit easier to deal with. What's the one on the left need? Needs y squared. What's the one on the right need? A 2. Very good. So the denominator would be 2y squared. Up top, right, 5y squared minus 2. Nothing to reduce there. Done. It's not. Okay. It does look really confusing at first, though. Once you get it, you got it. Last one, might require you to factor. if you notice, this bottom is x minus 3 and x plus 2. Sometimes that's going to be necessary to factor that because you might not need to give both factors away. But in this case, I can see what the left side needs is a 2, and what the right side needs is both of those blue ones, right? Okay, but here I'm gonna cheat. Since I'm gonna end up having to multiply it all together, instead of giving them like x minus 3 and x plus 2, I'm just going to give a x squared minus x minus 6. Okay, it needs that whole thing, right? But it's useful to me to leave it as the multiplied version here because I'm going to have to end up distributing this anyway. Maybe. I don't know. I don't know yet. Okay. So the bottom, 2 times x minus 3 times x plus 2. That's the bottom, right? You can call that x squared minus x minus 6. You can distribute the 2 in there and get whatever that is, but I'm going to leave it factored just in case I have something that cancels out or if I need to cancel. Yes, 2 times 5 is 10. And then be careful because you have to distribute a minus 3. It's not distributing a 3. We're distributing minus 3. So minus 3x squared. And minus 3 times minus x is plus 3x. And minus 3 times negative 6 is plus 18. I've got some like terms, I think. 10 and 18 make 28. So we're looking at negative 3x squared plus 3x plus 28 over 2 times x minus 3 times x plus 2. Could be. That could be a hard trinomial, but I'm not worried about that just yet. Okay? I'm not worried about that just yet. We'll get there. All right?